Hi, I'm Principal Sheep. Welcome back to the classroom. Today, I'll be teaching you about turning your pets and the center of gravity. This is very similar and requires understanding of the principle of moments. So I'll just teach you a little bit about moments before we start talking about the turning your pets and center of gravity so that you can actually understand what I'm talking about. A moment or torque is the turning effect of a force about a pivot, the point where something attached to it will turn from. It depends on two things: the size of the force and the perpendicular distance from the pivot to the line of action of the force. The equation is moment equals force times perpendicular distance. The units of moments is, the unit of a force is newtons, the distance is meters. And since you multiply the force and the distance, the unit of moments is Newton meters. Forces can only turn in anticlockwise or clockwise directions for the principle of moments. For an object to be in a rotational equilibrium, which means not turning, the total clockwise moment about a pivot must be equal to the total anticlockwise moment about the same pivot. The equation is total clockwise moment equals total anticlockwise moment, but I think you could have figured that out on yourself. We can use the principle of moments to solve problems involving balanced objects such as levers and seesaws. By equating the clockwise and anti-clockwise moments, we can find unknown forces or unknown distances. Now, I'll give you a few questions to see if you understood what I was talking about. Number 1, a force of 10 newtons is applied to a spanner at the distance of 0.2 meters from the nut. Calculate the moment produced. The answer is 10 newtons times 0.2 meters. So the moment is 2 Newton meters. Number 2. Two children are on a seesaw. Child A weighs 300 newtons and sits 1.5 meters from the pivot. Child B sits 2 meters from the pivot. What force does child B exert to balance the seesaw? The answer is the clockwise moment of child A is 300 newtons times 1.5 meters, which is 150 Newton meters. To balance it, the anti-clockwise moment, child B, has to be the same as the clockwise moment, child A. So the force has to be 2 meters times the force. And this has to equal 450 Newton meters. And so when you move the times 2 meters to the right, then it'll become 450 Newton meters over 2 meters, which is 225 newtons. The center of gravity of an object is the point where its entire weight appears to act. For a symmetrical object with uniform density, the center of gravity is at its geometric center. The position of the center of gravity affects the stability of an object. A lower center of gravity and a wider base generally lead to greater stability. The center of gravity of an irregularly shaped object can be found experimentally. And maybe hang the object from a point and draw a vertical line downwards from the point of suspension. Repeat this by hanging the object from a different point. The center of gravity is where the lines intersect. Now I'll give you another question. Why does a racing car have a very low and wide design? Explain in terms of its center of gravity. A racing car has a low and wide design to lower its center of gravity and widen its base. This increases its stability, making it less likely to tip over when concerning at high speeds, when cornering at high speeds, which is something a racing car has to do, otherwise it wouldn't be a racing car. And that is it for today's video. Please like and subscribe if you learned something new. 3, 2, 1.